our problem is another Newton's second law problem with kinematics this time. So we want to know what average force is required to stop an 1,100 kilogram car at 8 seconds. So we want to write our givens first. So our givens are m equals 1,100 kilograms. We also know the time is 8 seconds. Velocity is originally traveling at 95 kilometers per hour. Bless you. So that is its velocity initial. And what average force is required to stop? So what would be its velocity final?
0.
0. And I'm going to put 0 meters per second because eventually we're going to have to convert this to meters per second. We want to know average force, so eventually we are going to use what equation? What's our equation with force?
F equals ma.
Yep, F equals ma.
Why do you need kinematics? Can't you convert?
Okay, so this is why we need kinematics. We're looking for F. F is our unknown. Well, we have m, but we don't have a. We need to know the object's acceleration.
They gave us the velocity and they gave us the seconds that we needed. Can't we convert the kilometers per hour to meters per second and divide that by 8?
To find acceleration. Yes, we can. So that's what we're going to do. So first thing we want to do is 95 kilometers per hour. We want to convert to meters per second. So kilometers is on top to start with, but we want it on the bottom. So how many meters in 1 kilometer? So our kilometers cancel. And then we have hours on bottom, but we want seconds there, so our hours needs to go on top here. In 1 hour, there is 60 minutes. And then in 1 minute, there is 60 seconds. So our hours, you'll notice, cancel. Our minutes cancel. And we get, hoping you all have your calculators out ready to go.
26.389.
What was it?
26.389.
So 26.4 meters per second. Great. So that is our V initial.
Yeah, you have an extra calculator?
Their calculators are in the cabinet. Okay. So now we can use our equation for acceleration. Acceleration equals change in velocity over time, and just like below, notice, well, our velocity in final is 0. So we're going to just get A is equal to V final minus V initial over time. Our V final is 0 minus initial is 26.4 over 8 seconds. We get a negative, which is good because the object's slowing. And what's our value? Negative 3.3? Meters per second squared. Great. Bless you. So now we want to find force. Let's go ahead and plug those in. Well, here is A, and here is mass. So F is equal to 1,100 kilograms times negative 3.3 meters per second squared. And the force is?
3,628.47.
3.3 times 1,100?
Oh.
Did you round somewhere?
I got 3.299.
Okay, so with 3.3 it's what?
36300. 3630.
Newtons.
No, just one.
3630.
Great. 3,630 newtons required to stop the vehicle.
Not negative.
Because I was using exactly.
Well, it's required to stop it, so it's going to be the force that's opposing its motion.
Alright.
That's what the negative tells us. Okay? But the magnitude of the force is 3,630. Okay, let's do one more example. And I'm going to write it with you guys. Okay, 15 kilogram box is released. $15 kilogram box is released on a 32-degree incline that has negligible friction. What does negligible mean?
You don't got to worry about it.
Yes. Is that really the problem that we're doing?
Is it really the box?
What is the...
It says frictionless surface, but there's friction. Right?
So we're ignoring friction. That's what negligible friction means. So I want to know, what is the acceleration of the box? Okay, so let's draw a picture to start us off. Here's our incline, 32 degrees. Here's our box, 15 kilogram box. Okay, I'm going to draw directly on top of the box for the free body diagram. So what are our forces acting on the box since it's at an incline? Shivani, what's one? And what's its direction?
Force of gravity.
In what direction?
Down.
Straight down. And let's just call it mg. Let's start calling our force of gravity mg. Because that's what the force of gravity is. Okay? And our second force, Andy?
Can we call it MA?
Normal force perpendicular?
Still. Can we call it MA?
Yeah, because technically F equals ma also. That's where F equals mg comes from. Okay, and then a third force, Jessica?
Force of friction.
Is there? What is it? There would be, but what does it say in the problem? Negligible. So we're ignoring it. So is there a third force? No third force, right? But we do need to break our force of gravity into components. So here we have 32 degrees. That means here's our 32 degrees. And I'm going to go ahead and write what the x and y component is right now. There's our x component. So it is mg sine 32. And our y component is mg cosine 32. And now for our equations. So our system of equations, well, we have x forces and y forces, so we're going to need an equation for both the y direction and the x direction. So our y direction, F normal is going upwards, so F normal is positive. Mg cos 32 is negative because it's down, so minus mg cos 32, and that equals ma. Is the box accelerating up and down relative to the incline? No, it's not moving upwards and downwards, right? It's just sliding down the ramp this way, only in the x direction. So our A is 0. So we can simplify this. Fn minus mg cos 32 equals 0. So you get the normal force is equal to mg cosine 32. Plug in our values. 15 times 9.8 times cosine 32. What do we get?
124.66.
24?
124.66.
So that's the normal force. We ultimately want to know what is acceleration. Okay, so we may or may not have needed to solve that. Like I said, I always put down everything I know and then solve. Paul?
Why Fn minus mg cos 32 equal to ma?
Okay, so our net force equation is always equal to mass times acceleration.
Okay.
But in this case, our acceleration is 0. So before I showed you guys the equilibrium equations, right, and we just said whatever's up equals down if it's not accelerating. Well, this is where it originates from. I just didn't want to give away the Newton's second law yet. So now that we know it, we know where it comes from. That's how they're equal to each other, because acceleration is 0. Yes?
Is this somewhat similar to the video problem?
Yes, the video problem is just a little more complex. Okay? Okay, and then the x direction we have, well, the box is going to be sliding downwards, so that means mg sine 32 is our positive. Minus, is there a minus? No, so we don't have another force here. I'm just going to say it's 0. Okay, and then we have ma. And it's accelerating in this direction, so there is an acceleration. Well, what is common in both these factors? M, so we can cancel it out. So did we need to know the mass of the object? So we get acceleration is equal to g sine 32, which is what? 5.2 meters per second squared. There's our acceleration. Okay, so ultimately we didn't need to find F normal. When would we have needed F normal? Yeah, so if there's a coefficient of friction, if I actually said, you know, keep in mind friction, the coefficient of friction on the incline is 0.4 or whatever it was, then you would have needed this normal force. Okay? So that's it for our examples. I want you guys to get out